So if you were on the call a couple of weeks back, and it doesn't matter if you weren't, then I introduced Agile Integration as a concept, worked through how the world looks from an integration person's point of view, how things have changed over the last couple of decades. Today, what I want to do is look at it from a different set of eyes. I want to look at it from an application developer's eyes. See what the perspective looks like for them. So if we're starting to decentralize integration, that means that a lot of these integration experiences are going to happen in the hands of a developer. And so how are they interacting with the different integration patterns? Which things are their responsibility? What are the scope of those things, and so on? And so that will take us into some subtly different topics, but all still really wrapped around the themes of Agile integration. So it was worth dropping back a few years, first of all. So in around 2016, we put forward an integration reference architecture for integration, just a very high-level view of what a typical integration landscape looks like. And you can see from left to right, it's modernizing and becoming more decentralized and more fine-grained as it moves across. It's not my intention to talk to this diagram in any detail. I mean, if you want more detail, you can go to the YouTube videos that are on there. But I think that what's really, really clear from this is how technology aligned it is, how we've got layers of technology, layers of integration, layers of API management, and so on. And if we were to draw up something like that reference architecture today, it would really look very different. I would say I'm describing this as a target architecture for enterprises now, but we can see that the layers are more or less gone. There's still a notion of the fact that there are some systems of record that are more fundamental data, they're more likely to be on-premise and things like that, and there are some systems of engagement still that are more about the consumer focus. But at the same time, those technology layers have gone away, and they're blended into these individual applications. The applications are a collection of application and indeed integration components, as we'll see. And the applications are now truly representing parts of the business. They're parts of the business domain, which, to be honest, is what we've always wanted to do. It's more because we've always been, tied to the underlying infrastructure that we have to have a view that's slightly out of line with what the business does for a living. But these business components, because we can separate from the infrastructure more, we can represent those at the high level. So a few other things are very visible in this diagram. Grouping of things into, let's call them applications for now, with on the perimeter having a very clear separation between one application and another, controlled not just by APIs, but also by events. So events have now become a first-class citizen, if you like, in this enterprise architecture. We've always had them. There was a backplane for messaging and events in the previous one, but now they're very much sitting up there as a primary way of communication between these things. We could, again, go on and talk about this in much more detail, but let's move on to the topic of today. And I guess, just coming back to those personas. So a couple of weeks ago, I was talking about the red individuals on the left who are part of an integration specialist team, and how they might be in some organizations dispersing out into the application teams and helping them with their integration. And now today we're looking at it from the other personas point of view. So those application developer personas who are having to learn some of these integration skills themselves, look after pieces of integration infrastructure themselves too. And there's our 4-stage diagram. So this is the stages we walked through. 4 different stages that really represent the maturity of an organization in terms of moving towards a more decentralized state. Just summarizing very rapidly what I said last week, that most customers are somewhere between the first 2 columns of a heavily centralized ESB-based architecture, perhaps moving into having API management to control those things. And their target is to get to column 3 and 4, and probably a mixture of those two. So they're going to try and get to a place where their integrations are more independent, API management is more pronounced, and they've started perhaps to decentralize some of those integrations. And last week we were mostly talking about perhaps handing those integrations down into sort of system of record teams, this week we're going to look at the top layer. So we're going to look at what happens to the applications. Let's imagine taking an individual application designer or a team of them that are working on a complex application. How has their life changed, and how are they starting to become more closely involved with the tools of integration? How are event streams affecting them? How are they making use of API management, and so on? So we'll start on the very far left of the diagram, and I'm going to zoom in to what applications, let's see what applications used to look like if we go back a good 10 years or so. The things you had to integrate to were, from an application developer's point of view, very well known. Things that were less well known were well hidden behind something like an enterprise service bus. So from an application developer's point of view, you worked with a set of fairly common protocols. You had a database. It was probably a relational database. You connected to it using probably JDBC if you're in the Java world. You had queues. You connected to them perhaps generically over JMS rather than proprietary libraries and things. And then pretty much everything else was SOAP web services, and then more latterly JSON, HTTP communication. And your hope was that all the hard integration was done out of your hands by another team, and they would connect to all the back-end systems. And you exposed the work that you did, possibly as a website directly, but also, gradually over APIs. So using, again, SOAP web services and JSON. So there was integration to be done from an application perspective, but it was fairly known, sets of libraries and protocols that were well known, and the rest of it was pushed out into the other teams that performed the integration for you. Now let's come back to the diagram and switch to the furthest right-hand side, so the decentralized ownership. And imagine we're writing a well-decoupled microservice application. And let's have a look inside one of those microservice applications to see what we've got. So I've broken this application up into what you can see 6 microservices. In a real application that does anything substantial, you're probably looking at tens of microservice components. But this is enough to illustrate the point. It's there isn't one central monolithic piece of code. There's lots of separate microservices, and the benefit of having those as separate components is, as we described the other day, the agility. I'm able to make changes to those in a self-contained way. The fact that I can scale them independently of one another, so making really good use of the infrastructure underneath, and I can have different resilience models even for those different pieces. So there's a lot that I can do to improve the overall agility that I'm working with. And then dropping down a level, you start to see, well, yes, so I don't have a single database now that represents the reference data, or perhaps a replication of the data in a back-end system. I've now got a database for each individual microservice component. They're supposed to have their independent data store, and the only way that you communicate with that data store is through that microservice. And so that means, again, that you can change things independently. They can change the shape of that Mongo database, or the way they're storing things in a key value pair database like Redis, and so on. Now, there are a lot more different types of database available today. People look at lots of different NoSQL types of database. They still look at SQL databases too. And you're probably going to communicate to those databases over their own proprietary libraries. So there isn't a sort of a JDBC standard, because all of these data stores work in subtly different ways. So straight away there, we're seeing that the need to integrate with things, even within an application, is a lot more diverse than it used to be. And we've got other things we're bringing in to make a solution as well, where perhaps the ML model there means machine learning model. So you might be bringing in some aspect of artificial intelligence, cognitive aspects, where you train a model and then use that model to identify certain events and patterns in your capability. So again, you've got to work with those. There's a blockchain replica in here to show that we might have a shared ledger with other companies, with other partners, so that we can have a trusted database across all of us, rather than having to have complex business processes against differently owned databases whose provenance we've got no control over. So much more diversity in terms of the things we're connecting to, even inside that application boundary. We're exposing APIs, of course, so we need to expose towards the top of the diagram, expose the APIs that we create. And let's have a look around the edge. So on the left-hand side, Internet of Things, particularly prevalent at the moment with what we're doing with the pandemic. So there'll be a lot of contact tracing applications and more use of, how can we understand the sensors that we've got in the hospital and things like that. So lots of things that would be relevant to us in building new innovative capabilities that might enable us to make breakthroughs and make changes. And this is really what it comes down to, that a modern application is not only technically different and broken up into microservices and separate databases and so on, but its purpose is different. It's more likely to be drawing information from lots of different sources and using many, many different capabilities, more so than it ever was before, rather than just being a single monolithic chunk of code in a database. We're going to be connecting to many different enterprise applications, synchronously and asynchronously. We've probably got data spread across SaaS applications with their own subtle APIs that we've got to communicate with as well. So looking at a broad application scope, not an individual microservice, but a set of microservices that come together to create a modern innovation. We've got a lot going on in terms of having to bring data together from multiple sources in coherent ways and to create innovation. So modern applications look different technically. They have a different purpose from a business perspective as well. And if we look at that, what are the business requirements that are driving a move to more microservices orientated, cloud native styles of development? And I'm using those terms slightly interchangeably, but they are different. But cloud native is a sort of fairly encompassing term, as you'll see. And to a business, that really means I can improve how quickly I can get my products, new versions of my products to market. It enables me to innovate much more rapidly. I'm allowing it to, these much more lightweight architectures, allowing me to try much more radically different things, experiment with technologies that might have had too much lead time for me to get used to before. And in all of that, of course, especially with a potential recession of a size we don't know at the moment coming on the horizon as a result of the pandemic, I need to reduce my total cost of ownership as well. So there's a set of business requirements there, but that doesn't tell us anything really technically about what we're going to be doing. And the technical implementation, when we're talking to customers, what we're really hearing all the time is smaller, lighter, more independent. I want to be able to build small things quickly and explore them and change them quickly. I want to be able to scale them up and down and deploy them in different places. And I need them to be truly independent from one another. I need to have true resilience so that there's no danger of one thing taking out something else. How do I achieve all of those things to feed back into achieving those business requirements? And underlying all of this is some truly technical content as well, of course, and the move to containers for new applications is really fundamental to making cloud native work. Cloud native existed before containers became popular. They were certainly around, but they were popularized as after those sort of core things came through. But what we see is almost all new applications are centering around containers. There are still things written in VMs. Of course, people are exploring models like serverless as well, but the bulk is in containers at the moment. And there's something subtle in this diagram which I've drawn out deliberately. I've created a bigger distance between virtual machines and containers than between the other technologies, because virtual machines and bare metal, that was an infrastructure change, but you were still really working with a running machine. Containers is a different approach, and I'll talk in a minute about just how different cloud native is and then relate that back to how that affects the integration content. And containers, if you like, is a journey to serverless. Where we're trying to get to is a point where we are completely abstracted from the infrastructure and indeed the sort of servers that we're working on. And containers is a big step in that journey. So let's have a look at what those characteristics really are of building something in a cloud native style. Now, for those of you who know this territory, you might have expected me to share the 12 factors, and the 12-factor app principles are still very relevant today, but I looked at them a year or two back, and immediately felt that the language of them was somewhat dated. They are an old set of control points, and I felt we needed to have a fresh look at that. So this, based on the customer interactions I've had and the projects I've been close to and things like that, these are the key things that I hear people talking about when they're talking about cloud native. And as you can see immediately, it's not just about technology, it's about people and methods and the way that you run things as well, techniques like DevOps and Agile methods and so on. It's about the type of technology and the characteristics of the technology. So I need technology that it can become a small runtime that can be deployed as an image in a container in the right way, in the way that it should be done in a cloud native style, immutably, so that I don't have to deploy to it at runtime. I can just deploy new images and so on. I want to manage my infrastructure as if that's code too in a repository, and make changes to a repository and have that ripple through into my infrastructure. I don't want to be messing with the live running components myself. I want the orchestration environments like Kubernetes, or indeed OpenShift if you're working on top of that, to do that for me. Out of these, and we could spend a whole hour just talking about cloud native characteristics themselves, two of them immediately leap out as having a relationship to integration. Fine-grained componentry and strong decoupling. So we're going to break things into smaller pieces, which means we need to know how we connect those pieces together and how we expose them and control them. That's got some amount of integration relationship to it. And strong decoupling, that's got a number of different aspects to it. We need to make sure that we have a clear conception of what one component is and another component, and how they're joined together, and moving into asynchronous ways of joining those things together as well. So we can see how integration is clearly going to creep into this territory. So let's come back to our cloud native application and start thinking about the first of those aspects, which is API management. So we clearly have some of these components talking to each other within our application over APIs, and that will be one style of communication that's going on locally. There'll also be event-based communication. We'll talk about that in a moment. And we're going to expose some APIs outside of our application, as we would have done before. And we still need to expose those in a well-controlled manner. So anything that's outside of our application boundary is going to need a secure and configurable API gateway. And indeed, if we're going to expect our application teams to place their APIs on that gateway, then they're going to need to be able to do that administration themselves. And that's really where API management software comes in enabling an application developer to go and push their own APIs using an API manager, and configure a gateway that might be quite a complex gateway and expose things into a portal. And to some extent, we talked about a lot of this last week when we were discussing API management already. So one of the things to note is that, in what way is that cloud native? That's sitting on the edge of our cloud native application, but in what way is it cloud native itself? And the portal and the API manager themselves, certainly in our product, and I suspect in other vendors too, are now being rebuilt to be microservice applications. So they themselves run in Kubernetes environments. They are sets of containers that run in a cloud-native style. The API gateway itself is a container. We'll talk in a moment about the relationship between the API gateway and the way that you connect into a application in a Kubernetes environment too. So API management, providing the shell around the edge, as we've discussed before. And then we look at, and again, I discussed this in the previous week, that it's providing that shell between different applications. So it's making sure that we can keep these complex, fine-grained environments manageable. So each communication across an application boundary, we would expect to go through API management. We would expect a microservice talking to another API, another microservice in another environment, not to know even that it is a microservice. It would go through an API to get there. And so using those to create the sort of shell between those different pieces. What I didn't get to talk about a couple of weeks ago was what we do with the communication internally. So what about if a microservice wants to talk to another microservice that's in the same application boundary? Don't we want to have some level of control over that too? What if we want to do some routing based on versioning? What if we want to make some adjustments in that kind of way? And so is there some technique that we might be using to do that? And this is really where the service mesh concepts come in. And you may have heard of a service mesh called Istio. That's the one that IBM is backing, along with Google and Lyft. And that's the one that we believe offers the best sort of capabilities as a mesh between the microservices in a given application. So that then means that we have a way of doing a lot of the sort of the routing and the traffic management patterns that we need inside without having to put a gateway in between every single microservice. The way the mesh works is effectively just intercepts the communication between one container and another. It's actually done at the pod level from a Kubernetes point of view. So it becomes a sidecar within the pod, allows the interception of the traffic. So we could, for example, add in a new version of a microservice and only send a percentage of the traffic through that microservice. We could control the way we perform retries, rippling down through the microservices and an invocation path. We can set up trusted mutual TLS between the different components, and all of that can be done in a declarative way. So it's again in this kind of infrastructure as code kind of way, where we can control the way that the communication occurs between the pieces of the application using that. So we don't expect to see API management inside an application boundary, only on the edge of it. And then we expect to see the service mesh allowing us to manipulate the traffic going through there, and perhaps also using it for generic ways of drawing logs, getting tracing information, pulling metrics from those pieces as well. Now, you could then ask, well, okay, so is there some relationship between API management and the service mesh? And we believe there is. We believe that there will be context that only API management knows at the edge of the application boundary that needs to filter its way down into the microservice application and perhaps be used by that service mesh to affect the routing. So what we're enabling there is the ability to add things as headers that are then passed down into the, so things like, for example, the subscription plan that somebody's on. So what is it that, are they a gold plan consumer of our APIs? Is this somebody from our test users, so that we want them to go down a certain path to test a new version? Do we want to inject some kind of fault responses in, which again is something we could do using that sidecar. And so we could do that based on information that only API management has. So there's a very collaborative relationship between these two pieces. And we expect that to deepen over time as well. So we're expecting to have an even closer relationship between API management and what's called the Istio Ingress Gateway, so that those two things become very much more closely aligned. So that's a quick discussion about how within a given application we would expect to see communication done, the use of the service mesh in comparison to API management. And what it's pulled out very clearly is this: scope really matters. Whether we're talking about what happens within an individual microservice, across microservices within an application, whatever we define that application barrier to be, what happens across a number of applications that are perhaps in a business domain, and indeed how they communicate across domains within an enterprise or even outside of that enterprise. The answers at each of those levels about things like the data model, whether we're using the same data model, whether we need to translate the data model through an anti-corruption layer, whether we need to have a more protection, whether we need a visibility of the people subscribing to, say, events or APIs across those boundaries, that changes as we go up at the different scopes, at the different scales, if you like. And that's going to matter again, as we've been talking about it from an API perspective. That's told us something about where API management sits on the edge of an application, potentially at the edge of a domain, definitely on the edge of an enterprise. It will also tell us something about where we use things like events as well. So let's delve into events. That's the next logical thing to talk about. So in our new application, you saw a lot of dotted lines between the microservices. It's preferential if microservices can avoid real-time communication over APIs. That's not to say that everything will be over over events and asynchronous communication. There'll certainly be API calls between them, but the preference is to try and make things as decoupled as possible. Now, that means we need some form of event broker in here as well. And this is, as we'll see in a moment, I'm going to go on to the different patterns that we see here, but this is not the same as saying I'm going to continue to do the request response pattern that I was doing over APIs, but I'm going to do it over an asynchronous medium, which is often what ended up happening with traditional messaging and things like MQ. That's not what we're talking about here. We're talking about a very different usage and something that enables us to perform very different patterns here. Some of those patterns existed in the past as well, of course. Talking about that scale and scope that we talked about earlier. So we've got the event broker there, perhaps looking at mediating the messages that are coming through, publish and subscribe messages between different components within our application. That may be a different usage of an event broker, certainly different topics, to having events escape that boundary and start to move out into other applications, perhaps other domains within the organization. So it might, at the very least, have different topics, maybe with different data models for the events, but potentially we even have a different event broker. And so we can see this is something that needs to now be in the hands of the application team. The application team want to be able to stand up an event broker. Now, what do we mean by that? Well, for microservice applications, the preference today is mostly Kafka. So the open source Apache project Kafka, which provides an event broker that has a very specific and important characteristic of history, and a few other aspects to it as well that make it very well aligned with working in container-based environments and in microservice types of environments. And the application team are going to need to be able to provision their own capabilities, to create their own topics, work with that in their own way. It's not something they want to have to go necessarily to a central team to build a Kafka environment for them. But Kafka is not trivial. And anybody who's tried this will know that getting past the basic proof of concept and starting to productionize a Kafka capability is a non-trivial thing. So that's why we brought it into our integration portfolio in IBM as IBM Event Streams, and made it something that you can run a managed or self-managed or vendor-managed by us capability within your environment, so that you can make use of Kafka as something that is under your ownership, but without the complexities of the underlying framework itself. There's some new thinking around, as events escape a given boundary, like an application boundary, maybe they need a similar kind of management to we're doing for APIs today. So maybe we need a portal where you come and discover what events are available in a different domain, where you can subscribe to them so that we know who's using which events, who's going to be affected by changes. And so the idea of event management is something that we're actively working on. We expect to see that in future releases, and some of it built in already. So we can see here that, again, in that same decentralized fashion, we'd expect an application team to be able to administer their own events and say, this set of events should be available to these groups of people, and I'd like to redact the following pieces of information from that, and so on. Event-driven architecture is not a new term. It's been around a couple of decades, but we're seeing a rejuvenation of that because of the common use of capabilities like Kafka. And what's interesting is a lot of these patterns build upon one another. So we can start off with the basic publish subscribe pattern, and then start to see how people are using that to build projections, how they're using it as a source, data source, and so on. And so I'm going to walk through the patterns that you see before you now, and try and describe that kind of progression and how these sort of patterns build up and how they're used in the application space. So begin with the basics. So what does an event stream provide? Well, it's a first-class mechanism for providing publish and subscribe. That's really, it is fundamentally based around publish and subscribe. The difference between the modern forms and those that come before is that Kafka is very heavily focused on retaining the event log. So we don't allow people to subscribe and then lose the messages that they've heard. It's not transient, it's actually stored events in a history, which is achievable now with modern day technology and the cheapness of storage and so on, and also the patterns that they've used to spread the data across partitions and allow multiple subscribers to read those messages very rapidly. So basic distribution is something's happening in a back-end data store. As things change, it pushes things to the event log, and then that event log starts to distribute those to all the people who are subscribed. And in fact, they come using the Kafka APIs, they come and draw those events down by reading their way up the event log, but their event log, the event history, remains in place. Now, what are they going to do with those events when they receive them? They might well use them to arrive, to put notifications on screen, or change the way that things are displayed to a user, or to adjust the behavior of the applications underneath. But equally likely, they might want to work with those events in a more complex way. What we actually see here is that the events that are coming out of that back-end data store might well not be the granularity and the content that's required by those end systems. So another thing that's coming on top of that event history is event processing. From the very filtered, very simple, like filtering and routing and redacting, just removing elements from the event stream and publishing it to another topic. So the topics that people are listening to might be different to the topics that are coming from the raw data source. And that's moving all the way through to doing sort of complex event pattern matching to say, well, I'm going to produce events every time I see these three things happen within a certain window of time. Right through to doing analytics on those events, being able to go back and replay and do analytics across multiple different event histories, and potentially feeding machine learning models. So well after the fact, you could come back and feed a model to teach it how to behave in the case of certain events. Well, then what are we going to do with the events once we've got them? So we could look at saving some of those events locally. And event stream projections, the concept of a projection, is saying there is a back-end data store. Through listening to the event stream, reading through that event stream, I can build everything that's in that back-end data store in a local database that's close to my application. Modern applications require need to be exceedingly responsive, and so we're going to need to be able to have access to the data, even if the back-end system isn't available. We might want to query that data in ways that would be inappropriate if we were going to go to the back-end systems. So being able to have this local projection of the data that's in the back-end system is something that's very valuable to us. And of course, the event history then allows us to rebuild that local data store. So if we decide, oh, this isn't the right shape for this data, or I'd like to combine this data with data on another event topic, then you can go back and reread the event log and rebuild your local database in line with the rebuild of your application, such that everything works together. So you're not tightly coupled to the back-end data, as you definitely shouldn't be. Indeed, you're not even tied to the way it's exposed as an API or as a web service. You're only tied to your own local data store, and you can change that data store if you want. So bringing the agility that you really need for your application. So event stream projections is something that we're talking about a lot at the moment, but we often hear it under a different guise. And I'm going to introduce another couple of patterns which are subtly in this space. So event sourcing is something that we hear as a term quite regularly, and it relates to something very similar to this, but it's almost to the point where you say, well, I'm writing a new application or I'm refactoring an old one, and I want to move to a point where I don't actually need that back-end data at all, because I actually prefer the way that things are stored in an event log, in an event history. I think that's more valuable to the way I want to look at the data. I want that history of the transactions in someone's account, for example, or their shopping profile. I want all that historical data. And I actually value the way that it's stored in an event history. That tells me more information and allows me to do more things. So I now question why I need the actual back-end data store at all. An event-sourced application, a purist event-sourced application, takes that view. It says an event log is the only data store, and that's where all of the information about my data is. It might be spread across multiple topics, but that's where the information is. And so when something happens in the application, I'm going to add another, somebody's taken money out of an account, I'm going to take a debit event into the event stream and so on. But of course, how do I get hold of the data I need? So say I want to know what someone's current balance is, there's going to be some work needed to be done to fold forward all of the things that have happened in the event log to create that history. So the likelihood is I'm going to use that event stream projection concept that we had in the previous slides to do that. So I'm going to do some processing on the event log that brings things together into a data store in the format that I need. So if I'm doing an account summary, then it'll be listening for those changes to the account balances and bringing those together to tell me what the current balance is, for example. And so we'll have these local data stores that are really slaves to the master, and the master is the event log, not a normal data store. So it's, if you like, it's a Kafka being treated as a first-class data store in place of a database. Now, the use of the event log in this way is called event sourcing. But if you look at the pattern that we've had to wrap around this, we've had to say, well, every time I do something that's going to affect that data, I issue a command that becomes another event in the log. And then I produce these read-optimized data stores that are projections of the data in there. So I've actually got to a point where I've separated out the read, the commands that I'm doing and the reads that I'm doing against that data. And this is where we come to the term CQRS. That's Command Query Responsibility Segregation. And it's the pattern that you wrap around an event source in order to make it work, really. And it's the sort of the embodiment of how you code against that particular pattern. So CQRS is command and query separation, and we're seeing this term used quite a lot. From the outside of this, I've got it here as an application boundary, but I've also noticed it as a context boundary, which is a term from domain-driven design, from Eric Evans's book of a decade or more ago. It's very important to recognize that this is wrapped within a context. The fact that we've got an event log as the data store and that we're using the CQRS pattern should be completely hidden from somebody who's interacting with us. So perhaps the mobile application itself that's making use of this data doesn't have any idea that this is actually implemented in CQRS. It just calls APIs for making mutations to the data, for reading the data. It has no idea, in fact, that this is how it's implemented on the inside. And so, interestingly, we are back to scope again, because what we've just said there is that within an application boundary, a bounded context, a context where a single data model rules, and the name for well-known business concepts is the same. So we mean the same thing within this context by a flight or an order or a customer. Within that context, I could use the CQRS pattern and event sourcing, and I can hide it within there and I can use it consistently. But if I'm exposing it outside of that environment, then nobody should know. They'll come in through APIs, they don't know what I'm doing underneath. And it's really important, actually, this particular aspect, because this ties back to something we had earlier. Why is it that I had a separate idea of events leaving the boundary to the events that were happening on the inside? And the CQRS pattern is very closely related to this. Those internal events involved in the CQRS pattern should never escape in their raw form from that bounded context. That would be like exposing your raw database, the tables in your raw database. We already know from years of experience that we shouldn't do that. So yes, you may well have something that represents some of those events and some of the data in those events, but you'd expect to have made a deliberate choice as to what you expose, what fields you expose, and so on. And so we come back to what might event management help us do in this scenario to create that set of inter-domain events, if you like, that are going between one bounded context and another. And we can delve into this a little bit further. So on the left-hand side, as I say, within one bounded context, we've got an application scope. That's the CQRS pattern again I'm showing on the left-hand side with its internal events. On the right-hand side, I'm showing you something that looks like CQRS. You can see on the left-hand side the commands coming in, and on the right-hand side a read optimized database and some kind of event log at the bottom. It looks like CQRS, but we probably shouldn't be calling it CQRS because it's spread across multiple different contexts. Let me give you a business example for this one. So the store forward on so looking at the right-hand diagram, but the top left of it, the command store coming in there, that could be a point of sale system. And so it's working with the sales that occur through the day. At some point, those sales are then being sent via command forwarding over an API in this case, because we want to respect a boundary between two different systems, into some command processing in another context. That might be the inventory context. So we want to know what stock's gone as a result of that sale. There are many other things that also want to affect that industry. So that's a separate bounded context in its own right. Another part of the organization, a different team of application developers looking after that. Then there's some, they store that in whatever way they like. Now, as it turns out, in this case, they do have a data store. And then they feed an event log off the back of that. So it's not true event sourcing there. This could be an old inventory system that has an event, a data store, and that's how it works. And then the events coming from that are perhaps needed by the replenishment system. So at the top right, that might be the replenishment system listening to a set of specifically designed and filtered and redacted events from the inventory system. So not the raw events that are occurring inside, but a set of cross-boundary events that it's chosen to subscribe to so that it can perform the replenishment of those items of stock. And then it's got a read-optimized data store that tells it exactly what sort of inventory it has at the moment against what sort of projections we have and where it should be ordering and making changes. So that's spread across a whole enterprise. That's three very different components spread across a whole enterprise. And that's a very different thing to CQRS, which is within a bound context. And you can hopefully start to see how the different integration components, the event log itself, API management, potentially event management, are having an effect. And you may also be starting to think about exactly what component would you be using to perform something like event processing. One last pattern before we leave, a Saga pattern, which is actually, that was 1987, I think, that was originally documented, but it's come back into fashion again as a term for how you orchestrate or choreograph a set of separate interactions. It's commonly used in relation to chained chained events going between an asynchronous storage. So one piece of code does some work and puts something into an event or a queue, and another piece works on it, and then each knows what it's doing individually. They know how to choreograph their own moves, but nothing's orchestrating the whole set. But also orchestration is an alternative form of the Saga pattern as well. And these again work at different scopes. So if you start looking at the scope and things are happening at perhaps a very enterprise level, this probably should be being done by something like BPM, business process management. As you go down and down in the scope and you're doing things at an individual microservice level, you might use a Saga coding framework to do this. And somewhere in between, you might want to use something like an integration engine that already understands event-driven architecture and has patterns like aggregation, grouping, and fan out and fan in as part of its basic vernacular to perform this across a number of different things within perhaps an application domain. And so that's brought us back to our original diagram. And I want to take a look now at the language, what I've written as language runtimes on the original, because we would assume that those microservice components might be pure language runtimes. And how might we start to develop those out? So we could take a look at all the different things that we're connecting to and recognize that we're connecting to queues, to SaaS applications, and so on, and start wondering about whether, in fact, we ought to be making use of something that looks a lot more like an integration runtime. Now, as you can see with those blue boxes at the bottom, yes, of course, we would use that in the traditional service-orientated style, where the enterprise applications expose themselves, perhaps using integration runtimes over an ESB. We might break that up into smaller integrations, as we discussed a couple of weeks ago, that sort of idea of breaking those containers out. But that's happening outside of our application. What about within our application? What's happening there? And so we can see that, where we've got to perhaps orchestrate a number of different requests across queues, maybe we're doing them across a number of different SaaS applications, we're going to do composition, we're going to need data mapping, we want some notion of flow, we perhaps want something to help us with the aggregation patterns that we might need, we want something to manage connectivity for us, we want something that understands those SaaS applications in a first-class manner. Well, you could do that in raw code, but it has to be said that there's been integration engines out there that are more productive at that for a very long time now. And bear in mind what I said last week about how integration engines can now run in a lightweight fashion. They could easily run in in a particular environment, such as Kubernetes, quite happily acting as a true cloud-native component. So we should be considering them as an option. And as we start looking through the other parts of our solution, we might recognize that any one of the other things could be considered as a candidate for an integration runtime rather than a language runtime. That would be a perfect valid way to go forwards. It's just, accept that not everything is accessible as an API. APIs aren't always as easy to communicate with as you think. There are different forms of APIs. GraphQL is becoming popular now. So, the idea that integration has just become easy because everything's an API is really a myth. And we need to understand the complexities of the kind of interactions that we're making. Just move on to this slide. This is quite a rich slide. There's quite a lot on here. I'm not going to try and talk to it in detail in the time we have available, but what I wanted to do was not just suggest that you could use integration runtime, but actually show you which patterns would be more prevalent. I've used the dark blue coloring where I think that there's more integration going on than perhaps there is just normal language runtime coding. And you can see as we move into anything which sort of involves composition, anything that involves communicating with things that are outside our boundary and perhaps bringing those together in different ways. Certainly things where we're communicating with events and doing things in a composed way across those. We're definitely seeing more content of the work we're doing that would be suited to an integration runtime. So we come to a point where we're building new applications. We've got a new requirement that's come in. We use their concepts of smaller, lighter, more independent to build things, but we use that in the context of drawing in the other tools in the tool bag, and we draw in things that are integration focused as well. And so we make use of the fact that we can self-provision event capabilities, that we can look after our own APIs, administer our own APIs, potentially that we can use more productive runtimes to achieve integration and connectivity in the circumstances where that's appropriate. And that, with luck, will bring us to solving those fundamental business requirements, getting new products to market more quickly, increasing the type of innovation we can do by drawing together all these different capabilities, and doing this in things like container-based elastic infrastructures, which are more operationally standardized, so that we can perhaps reduce our total cost of ownership. I brought back one slide from a couple of weeks ago, actually, just to finish on. This was a summary of all the sort of concepts in Agile Integration that we focus on when we're talking about all the different aspects of Agile Integration. If this slide didn't say Agile Integration, and I asked you what it was about, you might just as easily have said this was about writing modern cloud-native applications. You might have said this is about application development. And I think that reinforces how, the two aspects are really coming together now. The idea of building a new solution, a new application, is as much an integration challenge as it is a coding challenge, as it is an analytics challenge, and so on. All of these disciplines are coming together, and teams are having to become much more multi-skilled. So with that, and with a little bit of time to go, I'm just going to take a look and see if there's any questions that we can pick off there. I can see quite a few have come in. I'm just going to have a look through. One of the questions is, how does the concept of integration platform as a service fit into all of this? And that's a really good one. So I've talked mostly about the idea of building discrete things within a microservice application, and really talking to people who are probably coders and application developers. But what about if you just wanted a platform where you could just build integrations? And that's an alternative here. It's almost the serverless end of integration. It's saying, how could I do this without really having to worry about how it lands? I just want to build integrations. And that's really what we've been trying to do with our integration designer capability, which is available on the cloud and on-premise as well. Bring a user interface that enables you to build integrations in a way where you don't have to even drop to code at all, and you don't have to manage infrastructure and so on. So that really does take us into another territory. And I think there will be a subset of capabilities that we will want to build our solutions out of in that situation. A good one here is, what if an application boundary spans across different cloud platforms? So I very neatly showed an application boundary that was sitting comfortably on an individual platform. And so what would happen if you'd built, or if you'd had to assemble together pieces that were across different cloud platforms, but actually as a whole solved one key business purpose? So the application boundary, if you like, was spread across a hybrid, perhaps on-premise and off, or across different cloud locations. I absolutely believe that is a thing. I think we have that in many customers I speak to. And it talks a lot to what we're hopefully able to achieve as we move to this level of abstraction, that we should be able to manage something that is across multiple clusters and clouds, but treat it as one environment, and be able to say these things perhaps have a trusted communication between them. And so the mutual TLS communication between them, and that they don't have to go perhaps through an API gateway to communicate, and so on, and be able to define that application boundary, even though it spans across multiple clouds, maybe multiple vendors of cloud even. So I think that's something that definitely we want to simplify. Today, that can be quite challenging to deal with, but we do need to get to a point where we can handle application boundaries across platforms. I don't think it's desirable, but I do think it's something we acquire occasionally.